A chemical reaction follows the following series of elementary steps. We have C going to form A and B in a fast equilibrium. We have A plus D going to form F in a fast equilibrium. And we have F going to form G in a slow step, which is the rate determining step. Write the balanced chemical equation for this reaction. First we must cancel the A's and the F's. And then we add to get C and D as reactants and B and G as products. Now we're to derive a rate law for this equation. The first equation is an equilibrium, so KEQ for number 1 is K1 over K minus 1, rate constants, and then over here we have the products, A and B, over the reactant C. For the second equation, because it's fast, we do the same thing. So K2 over K minus 2 is going to be equal to F, product, over A times D, reactants. For the third equation, this is going to be treated as the slow step, so we'll use a rate equation for that. The rate will equal a constant times concentration of the reactants alone. Now what we're going to do is we're going to do some fancy substitution. We start here with this F and we look for an F somewhere up over here. And there it is. So what we'll do is we're going to solve for F, and there's the solution for F, and we're going to substitute it in here. Do the algebra, and when we do, we get this. Now, we then have to come up to here. So let's take a look at what we would do there. You see that A right over here can be solved for, and occasionally there is more than one thing you can solve for, and in that case it doesn't matter which you choose. Alright, you should get the same answer. In this case we have A, and it looks like that's all we can use. Alright, and if I'm wrong, don't shoot me. Alright, so we solve for A algebraically, and then we plug it in here. And then we do the algebra and we get this as the answer, which is color-coded to show you where everything came from. Algebraically, it's not difficult, it's just a pain in the butt. But let's go back through the steps just so that you got a clear idea of what you do. So what happens over here is that you have your rate equation here, and you say, okay, F right over here, that's what we want to plug into. There's an F here, so we go ahead and we solve for F, plug it in. And then we look at what we have over here and we say, well, here we have an A and a D. We haven't used this equation yet. Well, the A, there it is, A is in common, so we take that, we solve for A, and we did that here. You plug that in and there you go. Arrange the terms to make them look nice. I've had people lose points, but they got them back when they put these in different orders, and Dr. Hoff couldn't figure out that they got the right answer. So it's better to go from 1 to 2 to 3 like that. Anyway, that's how you do it. It's loads of fun.